Hey Space Rangers, fourth graders, and anybody who wants to learn about the science of collisions. Collisions. Today we are going to talk about collisions. Collisions between marbles, collisions between a basketball and the ground, and collisions between cars. Not actual cars, little toys. So, a collision is just the transference of energy between one object and another object. When they hit together in the middle, there's a transferable energy that happens there that is going to cause some damage and some transfer of energy for an equal and opposite reaction. We see this a lot in our daily lives. We see it when a basketball hits the ground when you're dribbling. We see it when a baseball hits a bat and it flies off for a home run. We see all of this energy transferred from one object to another, from potential to kinetic, which we talked about in our last episode. So we are gonna go outside today and we're gonna play some basketball and see how a collision with a basketball and the ground makes a difference. We are going to smash some two marbles together and see how marbles of two different sizes affect each other when they collide. Then we are going to see how two toy cars colliding with one another at different speeds affect one another, if they are the same mass. So let's go do some science out into the world. All right, Space Rangers, we are going to talk about collisions. Let's change from sunglasses to regular glasses. Now, we have the collision of when the basketball hits the ground. When it collides with the ground, it bounces back up. The potential energy in the basketball and in the ground are being transferred. That potential energy from that basketball is being transformed into the ground. The ball then collides with the ground, creating an energy which is transformed back up into my hand. We're going to talk about different kinds of collisions and how if I push more down onto the ball will come up higher. All right, so if I just drop the ball at a small height, I just drop it. It doesn't make it back up to my hand, right? But when you push the ball to dribble, the ball always comes back up to your hand because the amount of energy you are pushing down on the ball makes the ball collide with the ground and come back up to meet your hand. The potential energy you are transforming into kinetic energy into the ball is then pushed onto the ground, and you will get the ball to meet your hand every single time. That's a swish for science. Space Rangers, it is time for an experiment where we take two different size marbles. These marbles are of different sizes and different masses, which means they weigh different. The bigger marble weighs more than the smaller marble. And we have a ramp of sorts that is just a flat surface so that we can have our two marbles collide. We have a small marble and a big marble. I'm going to place them at both ends and I'm going to push them with the same amount of force so that their collision should be equal in the middle. I want you to record and predict an observation that says, will the big marble push back? Will the small marble push back? Or will they just meet in the middle and not move at all? Let's find out. 3, 2, 1. Ooh, interesting. So what we just observed is the big marble and the small marble collided right about here. And they hit, and the small marble is pushed back off the track. Why do you think that is? Record it. Now that you've recorded it, I'm going to tell you what happened. So when the big marble, since they were both moving at the same speed, when the big marble collided with the smaller marble has a lighter mass. We talked about that the smaller marble weighs less than the bigger marble. So it down here collided and the energy transfer from the small marble was less than the energy transfer from the big marble. So the big marble knocked the small marble off the track because it was stronger. The energy transfer was stronger from the big to the small. Now, let's see what happens on our second test. We have a big marble and a small marble, but the small marble is moving faster. Speed is going to be a very important variable in this experiment. So, ready? 3, 2, 1. Ooh, okay. So, what we just saw, record it. All right, so what we just saw, I pushed the small marble faster into the big marble. Even though the big marble is bigger and heavier, the small marble was moving faster. So we see the energy transferred from the small marble into the big marble, and the energy transfer from speed was greater than the slow speed of the big marble. So we saw them collide, and the big marble actually was the one that rolled off. Did you think that was going to happen? Is that what you predicted? Now we are going to look at this experiment with cars. Collisions happen most with car accidents. That is the most realistic form of collision that we can visualize. So I have two cars here. They're the exact same car. They're the exact same weight and size. So now that we don't have two things that are different sizes and masses, what's going to happen when these two cars collide? What's going to be our biggest contributor to the transfer of energy? Starts with an S. Maybe you'll get it quicker than somebody else. Speed, good. Fast, slow. That's going to be the important variable when we are looking at this kind of experiment, because these two objects are the same exact object, just twice. So they are the same weight, the same size, everything. They are exactly identical. So when I collide them together, what's going to be important is the speed at which I push them. So let's see. Record in your journal, predict what exactly do you think is going to happen if I push them at the same exact speed. Do you think they're just going to stop? Or do you think maybe they'll push off each other? Maybe one will hit and the other will go this way? Think about it. I want you to think about it in real life terms of what would happen in an actual car crash. Who is going to get the most damage? This car or this car? All right, so 3, 2, 1. Ooh, okay. So they collided in the middle and they pushed back about the same distance away from each other because they were pushed at the same exact speed. So they collided in the middle and pushed back at the same distance because they're the exact same height and weight. Now, I'm going to push them, this one, I'm going to push faster and see if it has an effect on how far this one is pushed back and how far this one is pushed back. So I'm going to push this car faster and this car at the same speed as the first try. Are you ready? 3, 2, 1. All right, so we saw them collide in the middle. And the car that I pushed faster across the table actually collided backwards further than the car that I pushed at the same rate as the first experiment. Why do you think that happens? Please record it. All right, now, compared to the first one, I had them right here and I pushed them kind of at a decent speed. Now I'm going to take them way further apart and I'm going to push them both at a very fast speed and see how far I can get them, if I can get them to leave the table. Are you ready? 3, 2, 1. Interesting. So, no matter how far apart they were, if I push them at the exact same speed, they are going to meet in the middle. The energy transference is going to be neutral, which means that it is the same coming from both directions. They are going to equal each other out and just kind of hang out in the middle. We saw that they hit and they just kind of skid out and hit at the same thing. So think about two cars going on the highway. You're both going 65 miles an hour. You hit, you'll probably spin and land kind of near the same area. Compared to if this car is going 30 and this car is going 60, they will hit and this one will be pushed back because the transferable energy pushes them out of the collision and a further distance away. So think about that when we're talking about collisions.